Hello guys, how are you again? In this video, we're going to continue chapter 22 and we're going to start with section 2 hydrocarbons. As we said before, the hydrocarbons are the simplest organic compounds that contains only carbon and hydrogen atoms inside. And the first term we're going to talk about here is the saturated hydrocarbons, which are when each carbon atom in the molecule form 4 single covalent bonds with other atoms. So here we are talking about compounds that contains only a single bonds, no double bonds, no triple bonds. And we call them saturated hydrocarbons. And hydrocarbons that contains only single bonds are called alkanes. So this is the general name for hydrocarbons that made of single bonds, alkanes in general. This is not the name of the compounds, it is the general name of the compounds. For example, as you can see here, we could have this compound which made of 2 carbon atoms with 6 hydrogen atoms, and all the bonds here are single bonds. So here we have ethane. The second compound here, we have 3 carbon atoms with 8 hydrogen atoms, and the name of this compound is propane. And compounds that differ in this fashion belong to a homologous series, which is one in which adjacent members differ by a constant unit. It is not necessary to remember the molecular formula for all the members of the homologous series. Instead, general molecular formula can be used to determine the formulas. For example, the general formula for alkane is CnH2n plus 2, which means if we have 4 carbon atoms here, so N will be 4. So it will be C4H. 2N means 2 times 4, which is 8, plus 2, which is 10. So it will be C4H10. And so on. If you have C3, we will have C3H, 2 times 3 plus 2, which is 8. So the compound will be C3H8 or C5H10 and so on. Now guys, as you can see here, this is the molecular formula for methane, which is CH4, and the structural formula for it is also 1 carbon atoms bonded with 4 hydrogen atoms with 4 single bond. And this is the space filling model. As you can see, the carbon is the central atom and the hydrogen atoms are around the carbon atoms with a shape, we called it tetrahedral. This is methane, ethane here, and propane and butane. So as you can see, the shape actually in 3D is not exactly like the structural formula, because the structural formula shows only the number and type of atoms and how they are arranged together, but it doesn't show the arrangement in the space. This is something else. Here we have isomers of C4H10. The first compound is butane and the second compound is 2-methylpropane. So guys, if we're going to talk about naming, now we said that we have first, the name is alkane. So this is the general name. We will take a A-N-E from the general name. And we're going to count how many carbon atoms we have in the compound. And it depends on how many carbon atoms we use prefix to name the compound. So if we have a compound with one carbon atom, it will be meth. Two carbon atoms, it will be three carbon atoms, it will be prop. Four carbon atoms, it will be bute. Five carbon atoms will be pent. Six carbon atoms, it will be hex. And seven carbon atoms, it will be hept. 8 carbon atoms, it will be oct. And 9 carbon atoms, it will be non. And 10 carbon atoms, it will be dec. So remember that we are talking about alkane. So we will use this suffix ane. So if we have a carbon compound, a hydrocarbon that contains only one carbon atom, it will be meth, and we will add ane, so it will be methane, which is CH4. If we have two carbon atoms, it will be C2H. Remember that H here is 2N plus 2, so 2 times 2 is 4 plus 2 is 6, so C2H6. It will be eth, and we will add ane, so it will be ethane. 3 carbon atoms means C3H8, so it will be propane. 4 carbon atoms, it will be C4H10, and that will be butane. Sorry guys. Butane, add ane, and so on. So this is nonane, decane, and this is octane, heptane, and hexane. So we just take the prefix with the suffix. The suffix is always ane, and the prefix, it will be meth, eth, prop, and so on, depends on how many carbon atoms we have. So this is how we named the hydrocarbons. Now if we take this example, C5H12, we can draw it this way, C, 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 or we can draw it C. Now notice that this carbon atoms contain 3 hydrogen atoms, so it will be CH3. Here we have CH2, H and H only, so CH2, then CH2, CH2, CH3. Now this is structural formula, and this is, we called it compressed structural formula. We can also, instead of doing so, we can draw the compound starting from here. That means that here we have carbon 1, 2, 3, 4, and 5. So each stop here, or dot, or angle, means that we have carbon atoms here. So that means, this shape means that we have carbon here, and here, and here, and here, and here. And it is known by default that already we have H, 3 H's to this carbon atoms, and 2 for this one, and 2 for this one, 2 for this one, and 3 for this one. Because carbon must form 4 bonds to be stable. But actually, we don't draw the hydrogen here. And also, we don't write sorry guys. We don't write the carbon. We only draw 1, 2, 3, 4, 5. So if we have, for example, what about this compound? C3H. How many H's we should have here? 3 times 2, because it is 2N plus 2 plus 2. So H will be 6 or 8. So it will be C3H8. The structure formula, this is the molecular formula, C3H8. And the structural formula is 1, 2, 3, or the compressed CH3, CH2, CH3, or we can just draw it this way. 1, 2, 3 carbon atoms. And that's it. What about the name of this compound? Can you guess? We have 3 carbon atoms, so 3 will take prefix prop. And because all of the bonds here are single bonds, so it will be alkane, so it will be propane. We have also the alkanes could form a ring structure, and in this case we call them cycloalkanes, in which our carbon atoms are arranged in a ring or cyclic structure. We could have ring with 5 carbon atoms, it will be cyclopentane. So we just add the word cyclo before the name. So instead of saying pentane, which is C5H12, we add cyclo to be cyclopentane. So this is butane also, 4 carbon atoms, so it will be bute. And because all of the bonds are single bond, we add A and E, so it will be butane, alkane. If it was ringed, it will be cyclobutane. And notice that when we make cyclic formation here, we have to remove 2 hydrogen atoms. So the general formula for cycloalkanes is CnH2n. Because if we take this carbon atoms and this carbon atoms and we want to connect them together, we have to remove H from this carbon atom and H from this carbon atom here to be able to form the 4th bond between carbon and carbon. So 2 hydrogen atoms will be deleted from the compound. So it will be CnH2n only without adding the 2 here. As we said also, this is the systematic names, as you can see here. Meth, eth, prop, bute, pent, hex, hept, oct, non, dec. So here, as you can see, unbranched chained, we can give the name by counting how many carbon atoms we have. So we have 7 carbon atoms, so the prefix will be hept, and all of them are single bond, so we add A and E, the suffix, to form heptane. Now guys, this is easy when we don't have any branches in the compound, when we have only one chain. But what if we have some branches, as we can see? Now, branched chain alkane nomenclature. We have the alkyl group, and the alkyl groups are groups of atoms that are formed when one hydrogen atom is removed from an alkane molecule. What do we mean by that? For example, if we have CH4, this is methane. But what if we have CH3? This is not alkane. This is alkyl group, so it will be methyl. So this is CH3, this is methyl, and this is methyl. Here, we have 3 carbon atoms. If it was alkane, it should be C3H8, but here we have C3H7, 3 and 3, 6 plus 1, 7. So this is not an propane, it is propyl. And we use the names here when we named the organic compound. I will start with you with a very simple example. 1, 2, 3, 4, H, and H is here. How we will find the name of this compound? First, we have to find the longest chain in the compound. Longest chain means longest series of carbon atoms without changing the arrangement or the order. So we can start from here, 1, 2, 3, or 1, 2, 3, or 1, 2, 3. It is the same. So we simply just take this series 1, 2, 3 and make this one the longest chain. Now notice here that this carbon atoms is not included within the series. This is a branch in the series. So it will take something else. So the longest series here is 1, 2, 3. So because we have 3 carbon atoms, so we will have prop. All of them are single bonds, so it will be propane. So the name of the, let's say, mother chain is propane. What about this one? This is a branch. It will be named before the mother name. So this is branch of 1 carbon atoms. So it will be meth. It is not methane because it is not CH4. It is CH4 minus H, which is CH3, so it will be alkyl group. So instead of saying methane, it will be methyl. So this one is methyl. So we have here methyl propane. But where is the location of methyl propane here? Where is, at which carbon atoms the methyl is located? We count from here or from here, numbering the carbon atoms. So we can start from here, 1, 2, 3. We can notice that the methyl group is located at the second carbon atoms. So it will be 2-methyl propane. And when we make the numbering of carbon atoms, we have to make sure that we started from the side that ensure the lowest number for the alkyl group. For example, if we have 1, 2, 3, 4, 5, 6, and we have 7, and here we have CH2, CH3. this compound. Or it will be CH3, CH2, CH, CH3, CH2, 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 CH3. What about this one? We can start counting. So we have 1, 2, 3, 4, 5. We have 4 carbon atoms in a series here. Or 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. So we have 7 carbon atoms in a series here. Or 7 carbon atoms here. So simply we just take this one here and consider that this is the longest chain. 7 carbon atoms means heptane, and here we have this branch. And the branch, as you can see, is made of 2 carbon atoms. So it will be eth, but not ethane, it will be ethyl. So ethyl, ethyl heptane. Now, where is the location of the ethyl? If we start counting from here, from this side, 1, 2, 3. Remember, guys, that here we are counting the carbon atoms. 3, 4, 5, 6, 7. In this case, the branch is located at the 5th, so it will be 5 ethyl heptane. But if we start counting from the other side here, 1, 2, 3, 4, 5, 6, 7, it will be located at the 3rd carbon atoms, so it will be 3-ethyl heptane. So we have to start numbering of carbon atoms from this side to make the number of the alkyl group as less as possible. So it will be 3-ethyl heptane. So this is the name of this compound. What if we have, for example, another one? One, 2, 3, 4, 5, 6, 7, and 8. And here we have this one and this one. What about this shape? You have to remember that each end or start or stop represent a carbon atoms. So here we have 1, C, 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 and here we have C, and here we have C. Try to find the longest chain. Notice that the longest chain must be continuous, so we can see 1, 2, 3, 4, 5, 6. We can't go back to continue 6 and 7, 8, 9, no. It is a chain, continuous chain. Or 1, 2, 3, 4, it will be stopped. 1, 2, 3, 4, stopped. 1, 2, 3, 4, 5, 6, 7, stopped. 1, 2, 3, 4, 5, 6, 7, 8. Obviously, that this is the longest chain. So we have 8 carbon atoms. So we have octane. Now we have to start numbering. Notice if we start from here, the first branch will take 1, 2, 3, 4, 5, and 6. But if we start numbering from here, the numbers for the branch will be less. So we have to start numbering from this side. 1, 2, 3, 4, 5, 6, 7, 8. Now here we have a 3, this one, which is methyl, and here we have methyl. So we have 2 methyl branches. 2 methyl we can't write in the name methyl and methyl. Simply we just say dimethyl or trimethyl or tetramethyl and so on. Because here we have 2 methyl, so we just add di, so it will be dimethyl. Now, where is the location of the dimethyl here? The 2 methyl groups are located at the 3rd and 4th carbon atoms. So we write 3, 4 dash. So the name of the compound is 3,4-dimethyl octane. So here from the name, you can know that you have octane. So 1, 2, 3, 4, 5, 6, 7, 8. And at the 3rd group, 1, 2, 3 here, you have methyl. And at the 4th group here, you have methyl. And this compound is the same as 1, 2, 3, 4, 5, 6, 7, 8. Here you have C and here you have C. This is the same compound of this one. And remember that this compound or 3 and 4, they are the same because this one is flipping of this one. So they are not isomers, they are the same compound. This is all for our lesson today about how to name the organic compounds. As you can see here, find the longest chain and try to give the stable name for the compounds. And for you guys, these questions will be homework for you. I hope that you draw it and submit it at the platform. Give the name, the following compounds. Four compounds. I hope guys you solve it and submit the names on the platform. Thank you and be safe.